What's good, everyone? It's You'll Be Blessed here, making it clear, making it plain, opening up the heavens, for my teaching is like spring rain. And today we're going to write chemical names for ionic compounds using main group elements, transition elements, and some polyatomic ions. Let's look at our first example, CaNO3-2. When you have a combination of main group elements with polyatomic ions, then you really just need to research the names of the ions and name it. These are the easiest ones to name. This is not the time to be creative. Let's go over answers that you should not be giving. First, these are binary compounds, so they normally have two parts to their names. Ionic compounds are very simple to name, and we try to keep it simple. So do not just name the elements as you see them on the page. It is not calcium, nitrogen, oxygen. But wait, aren't you supposed to change the last name to IDE? Well, you can try that, but it's still wrong. We just don't name the elements as we see them on paper. It just doesn't communicate any sense or understanding of what the chemical is. Okay, I know what you're thinking. It has to end in IDE, but it can't be nitrogen and oxide, so it must be calcium nitroxide. I'm sorry to disappoint you, but nitroxide is actually an anti-cancer agent that's being researched right now, so it is definitely not this chemical. So as stated earlier, in order to name this simple ionic compound with polyatomic ions, you need to know the names of the polyatomic ions and the elements. Humble yourself. Go and find the polyatomic ion list of your choice and actually read the list and put the correct answer. Therefore, the chemical name for this chemical formula is calcium nitrate. The NO3 ion with a -1 charge is nitrate, calcium nitrate. Let's look to this example of an ionic compound containing polyatomic ions. The most natural thing for a beginner chemistry student is to name the elements as they see them. So you might think about writing nitrogen, hydrogen, chromium, oxygen, but that doesn't communicate any sense or understanding of what the chemical is. Let's try just changing that oxygen to oxide. Nitrogen, hydrogen, chromium, oxide. That's a lot to say, and it's still wrong. So maybe you remember to actually check your polyatomic ion list like you're supposed to do, and you realize that the first component is ammonium, but then you still end up naming the rest of it as you see fit. Ammonium, chromium, oxide. However, that's still too long, and it's still ambiguous, and it doesn't really tell me what's going on. It is just simply not how we communicate as chemists. Thus, you might need to go back to your polyatomic ion list and realize that Cr2O7 is actually dichromate. So the chemical name for this chemical formula is actually ammonium dichromate. Get your life together and use the polyatomic ion sheet of your choice. Let's look at this example of an ionic compound containing a transition metal and a polyatomic ion, FeOH3. Because we don't know the charge on the transition metal, we actually have to backtrack using the anion first. So first, let's just get the basic name of this chemical formula real quick. And we accomplish this by using the polyatomic ion list to verify what OH is, which is hydroxide. Hydroxide has a -1 charge. So we know this chemical is named iron hydroxide, but because it has a transition metal, we need to know what the Roman numeral is in the center. With hydroxide having a -1 charge, we need to multiply it by its subscript, which is 3. 3 times -1 gives you a -3. Since we know this is an ionic compound, the cation, iron, must have an equal but opposite charge. To verify that this is a +3 charge, we take the +3 and we divide it by the understood 1 subscript on iron, which still gives us +3. Therefore, the chemical name for this chemical formula is iron 3 hydroxide. Let's look at this example of a chemical formula of an ionic compound containing a transition metal and polyatomic ion. The first thing we want to do is use our periodic table and our list of polyatomic ions of your choice to verify what is PO4 and its charge. Then we can just simply name the compound, knowing that we need to get the Roman numeral for the center. So we find out that PO4 is phosphate. So this compound has to be niobium phosphate. But what is that Roman numeral in the middle? Let's backtrack. Now that we know that phosphate has a -3 charge, we need to multiply it by the number of phosphates that are in the chemical formula, which is 5. So 5 times -3 is equal to -15. Since this is an ionic compound, we know that the cation, niobium, must have an equal but opposite charge to the phosphates. So that must be +15. We can then verify the charge on niobium by taking the +15 total charge and dividing it by the number of niobiums based on its subscript, which is 3. Therefore, 15 divided by 3 gives you 5. Therefore, the chemical name for this chemical formula must be niobium 5-phosphate. Let's look at another example of writing a chemical name for ionic compounds containing transition metals and polyatomic ions. So the first step is to just figure out what the components are. What are the basic names of this compound? So we start with Cr on the periodic table, which is chromium, and then you need to check your polyatomic ion list to verify what PO4 is. PO4 is phosphate with a -3 charge. And so we write that. We know this must be chromium phosphate, but how do we find that Roman numeral in the middle and verify the charge? What we need to do is use the anion's charge and multiply it times the subscript, which is the number of anions in the compound. Since there are 2 phosphates in this compound, we must take 2 and multiply it times -3, giving us a -6. With this being an ionic compound, the total charge must be equal to 0. Therefore, the opposite charge of the cation must add up to a +6. Then we verify the charge on chromium by dividing by the understood 1 subscript on chromium. 6 divided by 1 is equal to 6. Therefore, the chemical name for this chemical formula must be chromium 6-phosphate. Thanks for tuning in to You'll Be Blessed STEM Education. I hope you were blessed by the contents of this video. And if you were, be sure to like, comment, and subscribe to this channel for more teachings that feel like a refreshing spring rain.